the previous limits that I'm showing you. So what you do with such limits is you need to understand that the limit. So this is the only thing that you need to know on such limits. So the limit of 1 over x when x is approaching either positive or negative infinity is still, is just equal to 0. Why do we say this? Imagine that this x is maybe 50,000. When you get your calculator, you try to put 1 divided by 50,000, you find that your answer is going to be 0.0000000. You have a lot of zeros. So in short, the limit of this when x is approaching infinity, the limit of 1 over x when x is approaching infinity is equal to 0. Yeah, it's somehow closer to 0. That's the reason why they just put it as a 0. Either negative or positive infinity still gives you the same answer. So we can now proceed. We can now start. So this is the principle. This is what you just need to master when you are dealing with infinity. Yeah, let me also talk about this. So this also applies when you have x to the power n. This n represents any number. It can be a positive 2, it can be a positive 5, a positive 6, positive 8, positive what? It can be a positive 1000, but as long as it's just 1 over x to the power n, any number, it will still give you a 0. So this is what you should know about such limits. So let's take, for instance, you have this part here. So to find the limit of this, you first need to simplify this part, as I said in the first place. So simplifying this part here, we're going to have something like this. So this is x squared plus 1. So if I want to simplify this, I want to achieve something like, maybe I want to have parts where I'm going to have 1 over x to the power any number this side. So how can I achieve that? It's by dividing all the numbers in this expression by x squared. So when I divide this x squared by x squared, and then minus 1 by x squared. In short, what I'm trying to say is I'm dividing everything in this expression by the x which has the highest power, and in this case, the x which has the highest power is x squared. So you do the same even on the denominator. So we're going to have something like this. All right. So I was saying you divide by the x which has the highest power throughout the expression. So I'm going to have 1 over x, this is a plus here, x squared. So here when you divide that by that, you have a 1, then minus 1 over x squared. And then even this side, we have 1 plus, so this is a 1 plus 1 over x squared. So we know to say the limit of a constant, which is the limit of 1. Okay, let me just write this. So finding the limit of this is just the same as finding the limit of 1 minus 1 over x squared over 1 plus 1 over x squared, like that. So when x is approaching infinity, so the limit of 1 when x is approaching infinity is simply 1. The limit of 1 over x squared when x is approaching infinity, remember what we said, is always equal to 0. So the limit of this when x is approaching infinity, we know to say it's nothing but 0. So we can say plus 0, then over the limit of 1 when x is approaching infinity is 1. The limit of 1 over x squared when x is approaching infinity is 0. So this is just the same as 1 over 1. So 1 over 1 gives you 1. So this is how simple these limits are as well. So we move on. So same applies to the second part here. So the second part here, you also divide everything by the x which has the highest power. So in this case, again, our x which has the highest power is x to the power 2. So you divide everything in the expression by x to the power 2. So when I divide this 4x squared, let me just say the limit of when x is approaching infinity. So the limit of that, when I divide this 4x squared by x squared, I'm going to get 4. And then when I divide x by x squared, I'm going to get 1 over x. When I divide 2 by x squared, I'm going to get 2 over x squared. Then everything divided by 5x squared divided by x squared, I'm going to get 5. And then this is going to be 4x divided by x squared. I'm going to have 4 over x. And then 1 divided by x squared, I'm going to have 1 over x squared. So I'm going to have something like this. So we know to say the limit of 4 when x is approaching infinity is just 4. The limit of a constant number, in short, is just that same constant number. That's the way it is. The limit of 1 over x when x is approaching infinity, we said is 0. The limit of this 2 over x squared when x is approaching infinity is also 0. Sorry, yeah, anyway, even if I put a plus or a minus, it will still mean nothing. But for the sake of understanding, let me just put the signs which are there. Same applies to the denominator. The limit of that will be 5. The limit of that will be 0, and then plus 0, which just adds up to 4 over 5 as our answer. So this is how you solve limits. They are simple and straightforward. Yeah, so
Mr. Teddy.
okay.
Mr. Teddy. Mr. Teddy. Oh, yeah, just a minute. So
Okay.
what if we're finding the limit of like x? It's going to be like 1.
The limit of what?
Of x, maybe like x, if there was x, or maybe like x squared.
Okay. And then when x is approaching infinity,
Oh, yeah,
it's going to be 1.
okay.
You know I've said it's going to be 1. And no, actually,
No.
it will not be 1. It will not be 1. Okay, let me just write what you're saying here so that everyone can see. So you're saying the limit of x squared when this x is approaching infinity, like that. So this is x squared. And then we know that this is just the same as x. Yeah, this is x squared. So this is just the same as x over 1, right? So we said we divide by the highest power. Yeah, but somehow it's going to be 1. Wait, I know. It cannot be 1 because when you divide this denominator by x squared, This will give you 0. It's undefined actually. It's undefined. Cannot be 1. It's undefined. Yeah. So proceed. Okay, the situation that you are trying to ask is actually the one that is here. It's the one that is in this question. It's also giving undefined as the solution, as the answer, because when you divide this x to the power 3 by x to the power 3, quite right, you're going to have 1. When you divide this t squared by t cubed, you are going to have 1 over t. And then when you divide that side, you're going to have 2 over t cubed. But on top here, you are going to have 1 over t when you divide by t cubed, and then plus 2 over t to the power 3. So this is what you are going to have. Let me just write this proper. All right. So this is what you are going to have. And then when you find the limits of these, when t is approaching negative infinity, you discover that all the numerator there, all the numerators there will give you what? Zeros. 0 plus 0, which will still add up to 0. Then there you have a 1. Yeah, for this one it's not undefined, it's a 0. I thought it will also give undefined. 0 divide by any number, you still get a 0. So for this one it's a 0, but the one that you asked was undefined. Yeah. So we do the last part here. The last part is the limit over x plus 2. The limit of x plus 2, and then everything divided by the square root of 9x squared plus 1. Then when x is approaching infinity, this one is a little bit tricky, so you need to concentrate, see what I'm going to be doing here. So here we know that the highest power is x squared, but how are you going to divide it? How are you going to do the division? So here what you do is you are going to, instead of dividing by, actually you're going to divide by x squared, quite all right? So you're going to say this divide by x squared. But remember what you have done here is what you have divided, this divided by x squared, even this one divided by x squared. But on the top there, on the numerator, when you're dividing, this is where the, okay, let me just rewrite this in a separate, let me write this separately here. So here on the denominator, I was saying you are going to divide by x squared quite right. So this would be 9x squared, even this x squared, then plus, to be 1 over x squared. But on this one, on the numerator, what you're going to do is instead of dividing x by x squared, you divide it by the root of x squared, and then plus 2 divided by the root of x squared. Don't know if you have gotten the reason why I've done that. So finding the limit of that, finding the limit of this when x approaches infinity will give you what this root, and that x will cancel, and that squared will cancel. So you just remain with x over x there, you get 1, and then plus this will give you 2 over, this will give you 2 over, to give you 2 over x, and then this will give you the square root of, this will be 9, and then this will be plus 1 over x squared. So when you find the limits of these, when you find the limits of these, you are going to discover that this part will be a 0, this will also be a 0. Hence, your answer is just going to be 1 over the root of 9, which gives you 1 over 3 as your answer. So this is how
Sound. So why were we dividing by the root of 2?
the reason
By
why
the root
I'm
of
doing that. Okay. The reason why I'm doing this, because I know to say, okay, imagine that you have something like this. Okay, or let me just, okay, what I was trying to show you was a shortcut, but let me just show you the whole process of how this is done. Maybe you get it. So what you are going to do is you are going to have the limit of x, or I mean the limit of that when x is approaching infinity. So I'll get this same thing here. This is x plus, and then 2 over the root of 9x squared, then plus 1. So this is how the expression is. Let me just write it properly. Yeah. So what I was doing at first, I was actually here what you do is you find the conjugate. You find the conjugate. That's it. No, what I did here was just a shortcut. But what you are normally supposed to do is to find the conjugate, and the conjugate that you are going to get. Actually, yeah, you find the conjugate, or rather, you find what is called a special one, such that when you multiply it with what is here under the side, it's going to leave this 9 independent. What do I mean? So here, if you are dividing with, I mean, if you are multiplying with something that you want, when multiplied with this, will give you this 9 to be independent, to be a constant. You can what? You can do this. This is what you do here. You multiply with something like this, and then you multiply it with also the denominator, also multiply it with something like that, such that when you multiply this times x, you are going to have this part here, and then you multiply this 1 over root x squared times 2, you are going to have this part there, and then when you multiply this times that, what is going to happen here is it's just the same as you taking this x squared inside. That's the way it is. Same as you multiplying the root of 2 times the root of 3. This is just the same as the root of 2, and then you take this 3 inside there, which is times 3, which is just the same as the root of 6. So it's just the same concept which I'm using there. It's something, you find something like a conjugate such that when you multiply it with what's in the brackets there, to leave at least one number a constant there. And of course, we should make sure that the one which is remaining as a constant is the one that is the coefficient of the variable which has the highest power. So this is what I was trying to explain here. Yeah, that's the reason why I multiplied by the root over x squared. I hope you've gotten the concept there. Yeah, we proceed to the next question. So here the question, I think if this one is not going to be the last one, if time is going to allow us, we'll also do the next one. So here the question is saying find, for the following curves, determine the horizontal, vertical, and oblique. So the oblique is sometimes called the slant asymptote, if they exist. So if you see this if condition, it means that there are some it means that there are some of the questions here which have one of these maybe missing, the vertical, horizontal, or the oblique, meaning there are some of the questions which do not have all of these here. So when we talk about the horizontal asymptote is looks like this. When you have the xy plane like this, the horizontal asymptote, if you it looks like this, passes like this. If this is your x plane, your x axis, and then this is your y axis, then this is the 0 there. So the horizontal asymptote always moves from the left to the right like that, and it's always y equal to a certain function or a constant just. Actually, for this one, in most cases, it's a constant. So I'll just put c this side. Y is equal to c. And then for the vertical asymptote, it's like this. X is equal to c. Let me use b in this case. Or d. It has written itself. Okay. So if this is d, you're going to have what x is equal to d as your vertical asymptote, and then if this is your c there, you're going to have y is equal to c as your horizontal asymptote. Then what are these asymptotes? These asymptotes are the lines which let's take for instance, you have your curve like that. An asymptote is simply a line which acts as a limit to the curve. So meaning the curve, no matter how long you can draw this curve, if this asymptote continues going like that, no matter how long you can draw this curve, to continue going, and it will continue be moving towards the asymptote, but it will never meet the asymptote. That's the way it is. It never meets the asymptote. And then even this side is to move the same way, but it will never meet the asymptote to continue going like that, but it will never meet the asymptote. So this is the vertical asymptote, and then this one is the horizontal asymptote. Now, how does the oblique asymptote look? The oblique is simply the slant asymptote. Oblique and slant is just the same. So for the slant asymptote, you have something like this. If this is your x-axis, so your slant asymptote moves like that. So you find sometimes to say that your curve maybe is moving like this, and then there's also another one which is moving like this. That is the slant asymptote. So this one is the one that we're calling the slant asymptote. Okay, so now since we know what a slant, horizontal, and vertical asymptote is, so now we can start finding them. So when you look at the first question there, you can determine the horizontal asymptote, the slant, and the oblique asymptote. And then how do you do that? So the slant asymptote is only possible, or is only found in an expression which has the numerator here, the power of the numerator greater than the power of the denominator. When you look at the value, the power of x on the denominator here is smaller compared to the power of the numerator. So meaning for the first question here and the second question, we can say they have no oblique asymptote, because the powers of the numerator there are less compared to the power of the denominator. Same applies to this. It has no slant asymptote. This one has a slant asymptote. This one has no slant asymptote. So the only one which has a slant asymptote is this one. Why? Because the power of the numerator, the highest power of the numerator is small, is big compared to the highest power of the denominator. So this one has a slant asymptote, and then the remaining ones do not have slant asymptotes. So when you talk of the horizontal asymptote, how do you find the horizontal asymptote? So finding the horizontal asymptote is just by finding the limit when x approaches infinity. The limit of this when x is approaching infinity. And then how do you do that? Remember what we were just from doing? What we are just from doing is what you do. So this is, in other words, the application of limits. So when you find the limit when x is approaching infinity, what you do is you divide by the highest power there. The highest power that we have is x. So when I divide x by x on the numerator there, I'll get 1. When I divide 2 by x, I'll get 2 over x. When I divide x by x on the denominator, I'll get 1. When I divide 3 by x, I'm getting 3 over x. So you find the limit of that, you are going to have the limit of a constant is always that same constant. The limit of any number divided by 2 when x approaches infinity is equal to 0. And then also the same here, denominator, you have a 1 there, and then you get a 0 there. Just remaining with 10 minutes. So 1 divided by 1, you get 1. So in short, our horizontal asymptote is simply y is equal to 1. This is our horizontal asymptote for this question. Then let us now try to find the vertical asymptote. The vertical asymptote is found by equating the denominator to 0. So in this case, our denominator there is x plus 3. So when you equate this to 0, the answer that you get, that is your, the value of x that you get, that is your vertical asymptote. So our vertical asymptote is simply x is equal to -3. So if this was to be sketched, the graph would come out like this. 0 to come out like this. So our horizontal asymptote, we don't have the oblique, so we'll not draw it. So our horizontal asymptote there is y is equal to 1. So this is 1. And then our vertical asymptote there is x is equal to -3. So it's somewhere there, -3. So if the graphs are to come out, I'm sure they would come out like this. To go that side, and then this will go like that. So this is how you sketch. This is just a sketch I was making. So we proceed. We move on to the next part here. In the remaining 8 minutes, I just hope that we're going to finish all this, because we've discovered that the only one which has the oblique is this one. So what you do to find the horizontal asymptote, we said you find the limit of that. So when you find the limit of that, you discover that your y is going to be equal to 0. That is your horizontal asymptote, because when you divide x by x squared, you get 1 over, I don't know why it's doing this. Yeah, when you divide x by x squared, you get 1 over x. When you divide 1 by x squared, you get 1 over x squared. And then when you divide the x squared by x squared, you get 1. 1 by x squared, you get 1 over x squared. Yeah. So when you find the limits of this this expression here, you discover that the top part there will just give you 0, because this is a 0, we know. This is also a 0. This is a 1 there, and then this is also a 0 there. So 0 divided by 1, you get your answer to be 0. So this is the reason why I said the horizontal asymptote was just y is equal to 0. And then the vertical asymptote, you equate the denominator there you equate the denominator to 0. And then when you get your answer to be, so your answer here will be the square root of, to be plus or minus the square root of -1. So this is a complex number. This is not a real number. They are all supposed to be real numbers. So if you get a complex number, it means that it has no horizontal asymptote. There's no horizontal asymptote. And to find the vertical is here. The horizontal, it has no horizontal, and then it has also no oblique because the power of the denominator is higher than the power of the numerator. So no oblique, no, we have no oblique, no horizontal, and then it only has the vertical. I mean, it only has, yeah, the vertical asymptote. Let us also proceed. So yeah, even this one also has the oblique asymptote because the power on the numerator is higher than the denominator. Even this one has the oblique asymptote. So I think let me just do this one in the remaining 5 minutes. So we find the horizontal asymptote. Horizontal asymptote, to find the limit of this when x is approaching infinity. And then you discover that when you divide by x squared there, you get 1. You divide by x squared there. So it has no horizontal asymptote because you're going to get something that is undefined. So this one has no horizontal asymptote. And then we find, sorry, this one has no, yeah, horizontal asymptote. Let us now find this one has no vertical asymptote. Let us now find the horizontal asymptote. So horizontal asymptote, it has no horizontal asymptote. Let us find the vertical asymptote. The vertical asymptote, you equate the denominator to 0. You equate the denominator to 0 to find the vertical asymptote. We equate the denominator to 0. So this is going to be equal to 1. So the vertical asymptote is x is equal to 1. That's the vertical asymptote. And then the oblique. Now this is where you need to get me clear. So for the oblique, the reason why we always say the numerator there is supposed to be, the degree of the numerator is supposed to be higher than the degree of the denominator, is because to find the oblique asymptote or the slant asymptote, you need to divide the numerator into the denominator. How do you do that? If you know synthetic division, you can use the synthetic, but for me, I like using long division. So this is how you divide. X minus 1, and then this will be x squared plus 1. So what you do when you're dividing using long division, where there is no degree there, you add a 0. So this will be a 0x, and then we have plus 1. So we can now start dividing this x into x squared. You get your answer to be x. And then x times x, you get x squared. X times -1, you get your negative x, like that. Then divide by the division line there. So you subtract now x minus x, x squared minus x squared, you get a 0. And then 0x minus x, you get a positive x. And then you're going to bring down this positive 1 there. Then you divide this x into x, you get 1. So you multiply that 1 times x, you get your x. And then 1 times -1 there, you get your -1. This is going to be x minus x, you get a 0. 1 minus -1, you get a positive 2. So this positive 2 is a remainder. So how you write this is like this. You write it in this way. So we know that this x squared plus this one here, this x squared plus 1 over x minus 1, when you divide it, this is just equal to x plus 1, then you say plus, you write this in brackets, and then plus the remainder, which is 2, and then everything divided by x, divided by x minus 1. Yeah, this is how you write it. So your oblique asymptote is just this part here. So your oblique asymptote is just this part, which is y. You can write it now as y is equal to x plus 1. This is your oblique asymptote. So the time is even counting down. I don't know if I should get maybe 10 or 15 minutes from you guys. We just finished the remaining ones here. Then we call it a day. Maybe tomorrow we'll come and start with first principle derivatives. Then we move on to finding the divide x, and then that. I want by Wednesday maybe we should be done with this. So I think let me just generate another link so that we just finish this question. Okay. So I ended on this one. So for this one here, we said since the degree of the denominator and the degree of the numerator are the same, so meaning it has no oblique asymptote, 1. And then let us try to find the vertical asymptote. So the vertical asymptote, I said you equate the denominator to 0. So I'm going to have something like 3x plus 2 is equal to 0. So when you calculate the value of x, when you make x squared the subject there, discover that you're going to have negative 2 over 3. Then finding the value of x will give you a complex number, which is the root of negative 2 over 3. So this simply tells you that the expression here does not have the vertical asymptote. The expression does not have the vertical asymptote. Yeah, so we can proceed. So the expression has no oblique